Welcome back, everybody. We're going to be looking at something called conformations today.
Professor,
Yes?
I have one question before I start.
Sure.
So for the common group naming, does it always have an iso or a sec or a tert in it?
No, there's many groups that do not have any of those patterns, so we have to use the systematic naming for those groups.
Oh, okay. So for the groups that you can
If you
just...
see, if you see the V pattern on the end, it's iso. If you see the branched methyl on the first carbon, it's sec. And if you see the double branched carbon on the first carbon, it's tert. You have to know those.
Okay, thank you.
And then we use the systematic name for the rest.
Okay.
All right. So moving on, we're going to look at what's called conformations. And this is, what is a conformation? Well, it is, how does a molecule look? How does a molecule look at a given moment in time? And I am not a good typer, as you can see, given moment in time. And the origins of molecules changing how they look is based on the fact that sigma bonds, which this molecule has nothing but sigma bonds, every single one of those bonds is rotating, and it's happening rather quickly. So, sorry, that comment, well, I guess that comment is, it's fine. I had to come up with this today when I realized I didn't bring my toys home, but I think we're going to get through it. We're looking at a molecule called ethane. It's got 2 carbons and 6 H's. And at one given instant in time, it might look like this. And there's going to be a name for that. And after rotating just 60 degrees, we see that if I call this carbon 1, and I'm looking at it this way, right above my head is hydrogen 1. And if this is a hydrogen here, I'll call that 2. And that is to my right. If I'm over here, every wedge is to my right because it's sticking out of the page. And it's on the front carbon. So that's 2. And to my left is a dash. That's 3. And on the back carbon, we'll go 4, 5, 6. 4 is right behind 1. If my eye is here, then 1 is in front of 4. So 4 is almost hidden. In fact, if I drew this even more accurately, the 4 would be so far right behind the 1 and I wouldn't even see it. That's going to explain its conformation name being eclipsed. I'll write that down in a second. 2 is right in front of 5. And it's to my right, because if I'm over here, these 2 are to my right, and these 2 are to my left, because I put my eye here. So 2 right in front of 5, and I didn't even put it, I moved my 3 instead of copying it. 3 is in front of 6. 3 is right in front of 6. So when I do my sigma rotation, I'm not rotating this carbon. I'm going to keep it the same. As you can see here, that carbon didn't change. And the back carbon, if I rotate that direction, this used to be here and I rotated it 60 degrees. It's going to end up on a dash about right there. And that's that. If I rotate this 60 degrees, it's going to end up in the plane of the page because it's rotating this way as the arrow shows right here. And the 6 will be right here. And the 5 is going to be, it used to be out in front, and now it's going to rotate up to here. Still out in front, but up there. Now, you don't have to do this on a test for me. So keeping the front carbon exactly the same, we have 1 and 3 and 2. Nothing moved there, but 4 rotated to about right there. Oh, didn't want to do that. 4 rotated to about right there. That's this one. And it's the 4's there. The 6 used to be here, and it'll be over back here. Yeah. And what's left is the 1, 2, 3, 4. I need a 5. It's right down here. Okay, so from the Newmans, I hope it's easy to see why this conformation is called eclipsed. And the most important thing about a Newman conformation or a Newman view is that the ball in front, you see the carbon right here. That's the front carbon. That's this carbon here, the big ball. But right behind it is a carbon, but I don't see it. Why? Because it's right behind this carbon, and my eye's looking this way now. It's blocked. But I see the thing sticking off of it. 1 is right in front of 4. There's the 4. 2's in front of 5. 2's in front of 5. 3's in front of 6. 3's here. 6 is here right behind it. And that's the eclipsed conformation. And you'll notice the hydrogens here are very close to each other compared to here. So you can probably guess, this one's not going to be called eclipsed. I'm just editing. There's a better and more even spacing, so it's called staggered. That's a staggered conformation. And the molecule is going to spend more time over here. The molecule spends more time staggered than eclipsed because because the H's are further apart. And if you have 2 nuclei close to each other and they're not bonded to each other, they repel each other. Spends more time staggered than eclipsed. Okay. So ethane, the molecule, spends more time looking like this than it does this. Sorry, more time looking like this than this. And this is a easier way to see why they have these names. Look at the nice even spacing going from front to back to front to back to front to back. Very even spacing. 60 degrees, 60 degrees, 60, 60, 60. Hey, 60 times 6 is 360. We went all the way around. Here the spacing is 0 degrees. Spacing equals 0 degrees. One's right in front of the other. Equals 0 degrees. And the spacing we're going to use instead of that word. And it's a good description. I actually like this word, even though it sounds a little fancy. Dihedral angle equals 0 degrees. I erased too much. And here the spacing between, I'm looking at a pair of hydrogens here, so I'm just going to circle them. There, the spacing between those is 0 degrees. And the spacing between, I might have to use one of these guys. Try to get 1 and 4 in the same circle. It's not going to be easy, but let's do it. There we go. That's not terrible. And the spacing there is not 0. It's 60 degrees, which is a lot bigger than 0. Call it a dihedral angle. Let me explain the word dihedral now. The front carbon is a tetrahedron. The back carbon is a tetrahedron. Dihedral means 2 tetrahedra. I'm comparing a group on the front tetrahedron to its relative orientation to the group on the back carbon, the second tetrahedron. And the angle between those is 0. And in a staggered conformation, it is 60. All right, so we got that, page 1. I'm going to put these into Starboard later. It's going to be a little more work for me today. Page 1. Now we're going to switch over to, instead of ethane, we're going to look at butane. I'll save as page 2. And we're going to change this to butane. And butane will have, oh, it was already, what are you doing, man? Sorry, talking to my computer again. CH3 and CH3. Oh, missed. And we're going to have to edit all the way around. So the 4 groups now is CH3, as is the 1 group. So the 1 is a CH3 and the 4 is a CH3. The 1 is a CH3 and the 4 is a CH3. And we have a 60-degree angle between those. And let's fix our bottom one. CH3, CH3, right on top of each other. Box a little bigger. Okay, so this is the least stable conformation here. We're going to see, I think, 5 conformations. Of the 5, least stable of 5 conformations. This one right here. Okay. And this will be the second most stable. It's a staggered conformation, but it will be the second most stable of the 5 conformations. Staggered is always more stable than eclipsed, okay? So let's carry on. We could do another staggered conformation, sigma rotation of negative 60 degrees. And we'll sneak that over here. And let's see what happens. Negative 60 degrees. So instead of rotating the methyl from here to that position, and the methyl would be on, oh, this is going to be harder than I thought. That's methyl's always the 4. And that makes the other one an H. And I believe that'll be the 6. Don't worry too much about the numbers, everybody. The only point I want to get across here is that these 2 will have the same stability. Put this down here. Flip horizontal. I just hope I don't miss anything. That's now here, and it's 4. Get the 6 out of there. Get the 5 out of there. Get the 4. That's an H now, isn't it? I hope you see they're the same stability, these 2. Same stability. And let's see, up top we got the 6. And down bottom we got, is that going to be right? I think those get switched. There we go. No, the 5's 5 straight down. I had that right. Yeah. Okay. These 2 are the same stability. They have a name. Those 2 have a name. And the name of the conformation, it's staggered, but there's a more specific name with a dihedral angle of negative 60 or 60. Dihedral angle is negative 60, which to me is the same as 60. Just different direction, right? The name of this conformation, to be more specific, is Gauche. Gauche is a French word. It means left, but this has nothing to do with left and right. In our language, English, we have stolen this French word. And if you're called gauche, it's not a compliment. It means you're uncultured, a little brusque and rough and not sophisticated. Anyway, nothing to do with gauche conformation, just words. Okay, so that's the Newman. We have these are tied for second most stable of the 5. And this is the worst stability of the 5. If we rotate 60 more, I'm not going to keep doing this back and forth. Everything I did to the right will give the same result as going to the left, okay? And I'm going to just say 60 more. Rotation of 60 more from here. And let's see what we get. I think I'm going to have a little trouble with my, it's going to be one of these, isn't it? Yeah. Oh boy, I got extra. All right, so the methyl is now going to be, we're continuing our rotation, so it's going to be right behind this thing we called 2. Now that's an H, and the methyl's the 4. Methyl's the 4. Going clockwise, I rotated the 5 60 degrees, so it's now, we're talking a back carbon here, right? It rotated to here, used to be here, now it's behind the 3, 60 degrees, right? And the H that used to be, let's see, the 6 rotated 60, it's behind the 1. And there you have, and this is another eclipsed, isn't it? It's another eclipsed. Is it as bad as the first eclipsed? No. A CH3 group is a lot bigger than an H. So when I have 2 CH3s on top of each other, if I did bring my toys, I would have been able to show you. They're almost touching each other. This is terrible. That's a very negative interaction. But there's a little room between a CH3 on a front carbon and an H on the back. So this is eclipsed, and it's the second least stable of the 5. It's not as bad. The groups aren't as close to each other. Second least stable of the 5. So we have 4 conformations out of the 5, I think. I'm not going to show the mirror image of this one, but it would be the same result with another sigma rotation of negative 60 here. It would just take a lot of time to get a mirror image of this picture, okay? But if I just keep rotating 60 more on this one, sigma rotation of 60 more, let's see what happens. It's going to be another staggered, by the way. And let's go from this one and fix it. So when I see, I didn't write the dihedral angle of my previous one, did I? What is the angle between the methyl groups in this one? We got the methyl here. What's the angle to the methyl here? Well, halfway is 60, all the way to there's 120. So 120 gave another eclipsed. Let's rotate this 60 more. It's hard. We'll get through it. Okay, another staggered. Oh, wrong. I copied the wrong one. We're going to go to something like this or this. Yeah, this is a lot easier when I use toys. I grabbed a lot of extra stuff. And we're down here. What happened? We're keeping rotation of this carbon 60. So it's down here now, the 4. That's an H. Oh, I didn't do that. And we have a 4 here. And we rotated the H that used to be called 5. Nope, 3 stayed the same. 1, 2, 3 are all the same. The 5 rotated from here, 60, so it's right there. And the 6 rotated 60, so it's here. This circle's meaningless. We like to compare the two hydrogens. Methyls, I'm sorry. So what's the dihedral angle between the methyls here and here? Dihedral angle is 180. And the dihedral angle was 120 here. I don't know if I can get a nice circle on the two methyls there, but the angle's 120. And this is the best of all the staggereds. Do you know why? This is the most stable of the 5 conformations. Most stable. And the reason is we got the biggest groups 180 degrees from each other. Okay, I'm just going to make a comment here. Mirror image not shown here. Angle equals negative 120 degrees. Yeah, negative 1230. Fat fingers on the 2 there. Okay. So what we have here is something that can be graphically represented. I'm going to steal something from the book. And I missed it. I know you don't see what I'm doing. I'll be back. There it is. And we're going to bring it to page 2 of Starboard. And Starboard is currently here. We need a new page. First page is going to be the chem draw that I just did. It'll show up on the first page. The second page is here, stolen straight from the book. All righty. And we have the most stable one down here is the staggered with the 180 dihedral angle. DA on this page is dihedral angle. We talked about that. And you'll see rotating the back carbon, so CH3 is there, gives this. Rotating the back carbon, so CH3 is here, takes you to the other side of the graph, gives you this. Look at, they have the same energy. They're the second least stable. Rotate the back carbon 60 more here. You get this. You get the gauche, which is not quite as good as this, the anti. Oh, I didn't tell you what's called anti. Better go back and fix that, huh? Has a name. Staggered equals anti. Staggered name is gauche here. Staggered name is gauche here. Staggered name is not gauche here. It's anti. And that's a nice word in chemistry. It means opposite sides from each other, 180 degrees. This was not the last time we're going to use the word anti. So that's going to be page 1. Maybe I should make it that before. I probably would forget if I don't do it right now. Let's see how it looks here. New version of this. And I don't need all the extraneous stuff there. Did I get everything? Pretty much. Yeah. And we're going back to Starboard, page 1. Okay. Oh, I didn't save it yet. You can see where I save stuff. HFC, AAA lecture, fall 2000. No, we're 241 fall 2020. There. Okay. So there we go. In summary, we have the least stable conformation with the big groups right in front of each other. 60-degree rotation in the negative direction gives this gauche. 60-degree in the forward direction gives this gauche. 60 more degrees gets you eclipsed. So Why is this one not as stable as, or more stable than the original? Because these groups, that's a big group behind a small group and a big group in front of a small group. Big group in front of big group is the worst possible scenario. 60 more degrees is going to get us to the best conformation where the largest groups are 180 from each other. This is another staggered conformation called anti-butane. The molecule spends more time like this than any other conformation. Spends significant amounts of time like these two because they're lower energy than these three. Spends the least amount of time up here. And that is a good stopping point for our study of conformations part 1. Next up, we're going to start looking at conformations in rings and spend till 6 at least on rings. So hopefully I do this right. I've got extra stuff going on today. And I'll see you in about 5.